Hello friends, welcome to Electrical Circuit. In this video, we will learn about Kirchhoff's law. Our main focus will be on Kirchhoff's voltage law. So, let's get started. In 1845, German physicist Kirchhoff had given pair of rules, which are known as Kirchhoff's law. So, first rule is current rule, while another one is voltage rule. Basically, Kirchhoff's current law mainly deals with current flowing in closed circuit, while voltage rule deals with potential difference in closed loop. Before learning these laws, we should firstly understand basic terms associated with circuit analysis. Here, first is circuit. Circuit is a closed path in which current is flowing. Path is defined as a line which connects source or elements. Third is node. Friends, node is a one type of junction point where two or more branches meet together. Fourth is branch. Branch is a group of elements or source which connects two nodes. Next is loop. Please keep your attention here because loop and mesh are most confusing terms. So, loop is a closed path in the circuit where any node is not repeated twice except starting node. While mesh is also closed path in the circuit with no other loop inside. Now, we will start with Kirchhoff's voltage law, also known as KVL. KVL states that algebraic sum of voltage in any closed loop is always zero. Friends, here two terms are very important, algebraic sum and closed loop. Let's understand this with a simple illustration. As mentioned in circuit, two voltage sources are connected with three resistors in the series. It can be noticed that this circuit is making closed loop and due to this I current is flowing in it. Because of this current, there will be a voltage drop or potential difference between these all resistors. Here we need to elaborate concept of algebraic sum. So we should remember two things. First is voltage drop, denoted by negative sign. Second is voltage rise, denoted by positive sign. Now, if current is flowing positive to negative, it will be considered as voltage drop, and if current is flowing negative to positive, it will be considered as voltage rise. Here, current is flowing positive to negative. So, it will be treated as voltage drop and equation for this is as mentioned. However, for E1, current is flowing negative to positive. Hence, it acts like voltage riser. So, positive sign is given to E1. Ultimately, what is happening? Amount of voltage or energy will remain consumed. Hence, it is also known as conservation of energy. This concept could be understood nicely by example. Friends, let's consider a simple circuit with having a single loop. I current is flowing in the loop. Current is flowing in clockwise direction. As we have discussed earlier, here current is flowing positive to negative, so it will act like voltage drop. Voltage drop equation can written as mentioned. By simple mathematical steps, amount of current can be determined. After this, we can also find voltage drop in all resistors by Ohm's law, that is, product of current and resistors. A statement states that summation of voltage drop in the loop is same as voltage source, and it is conservation of voltage. It was only one loop, Now we will practice on two loop circuit. So here in this circuit diagram there are two closed loop, loop 1 and loop 2. Let's assume current I1 and I2 is flowing in the both loop respectively. Two voltage source of 28 volt and 7 volt is connected with it, and three different valued resistors are also connected. For loop 1, as per the direction of the current in loop, we can mark potential difference near R1 and R2, and equation can be written as mentioned. But friends, simultaneously current I2 is also passing through R2. However, direction is opposite to earlier, so here positive I2 R2 shall be written. As discussed before, in 28 volt battery, current is passing negative to positive. So, we are supposed to write positive sign. Here, direct simplified equation is mentioned. Same for loop 2. As per the current direction, resistors are marked with voltage drop sign. Now, current is assumed to pass positive to negative in battery. Hence, as per our sign configuration, voltage source should be denoted by negative sign. Here, again two current are passing through R2. However, in this case, I1 is flowing in opposite direction. After solving the both equation, we will get current from loop 1 is 5 ampere while current in loop 2 is 1 ampere. As soon as we know about loop current, we can calculate voltage drop in each resistor using Ohm's law. Friends, here we need to always remember that two current I1 and I2 is flowing through R2, but direction is reversed. So finally, from R2, effective current 4 ampere will flow downward. Hence, 8 volt will be dropped across R2. So, this was all about Kirchhoff's voltage law. After watching this video, we can conclude like that we have learned about what is Kirchhoff's law, terms associated with circuit analysis, Kirchhoff's voltage law and numerical practice based on KVL. In upcoming video, we will focus on Kirchhoff's current law. We will see nodal analysis and we will also practice on numerical. Stay tuned for upcoming video. Kindly do like, share and subscribe this channel. Press the bell icon for regular updates. Thanks for watching.